Good morning, good evening, how you guys doing? So we have a new update to Shaketune. It's Shaketune version 3.0. There is one minor change and one major change. The major change is going to be to vibrations calibration. It has been renamed. We'll get into that. And so let's jump into it. Below is my Clipper version I'm using and Mainsail version I'm using. Once again, our test machine is the VT, it's a Trident 350, serial 1190. You can see all the mods I got going on here. Since I play, this is my test rig, I basically don't have the bottom, I'm using the inverted electronics, and I don't have the thing on because I replace everything all the time. I have been trying out these Voron Trident auxiliary fans. The link will be in the description for them. That's these green things on the side. They were modified from 24/7's V0, so a little speed demon thing. What I have found so far is for basically a 350 size, and I'm going to assume a 300 size, two sets of fans, or one set of fans, two fans, is not enough. You're going to need a curtain of air over this thing, so you probably want to get two of these on a 350. You could fit them in. I haven't tried them on my 300s. But I'm thinking gonna need two there. I'm thinking they're gonna fit. It's just not enough airflow for over the curtain. It's just the V0, the 24/7's V0 is a lot smaller, obviously. So the fans, two fans, are closer together. Probably about, here's the other fan of the V0 will be about here. So for the 350, I'm gonna try it with another set of fans. One's just not enough. But that's not why we're here. So, Shaketune 2.61-2, the last release before this update. This is what it looked like. You had your belt tension, your input shapers, and then you had your vibration calibration. Let's just get rid of this thing here. We don't need that. So this is kind of the standard of what everything looked like. I got a whole bunch of videos to describe each of these graphs and what do they all mean and how to read them, and this one too. Just as a recap, since this is going to be the big change here, this is how you're going to set your speeds in your slicers to avoid the noise created by the motors. So we're not looking necessarily at the dynamic performance per se of the machine in regards to acceleration. That is Input Shaper's job. Input Shaper takes care of your accelerations, your perimeter accelerations, internal and external. Vibration measurement took care of your internal, external speeds, and it would do this by setting lower acceleration, 3,000, because the goal was to get the goal is to get your tool head up to its speed that it's set at. So for example, if I set the tool head the speed at 100, you actually wanted to measure what the vibrations of the motors were at 100. So you want to get there fairly quickly, but not too quickly, because you don't want to induce dynamic effects such as tool head vibration. So what does Shaketune 3.0 do for you? So Fricks has removed the belt shaper name. It's not really a shaper because we're not shaping the belts. He's renamed it to compare belt responses, which is a more accurate description of what is happening with the belts. We are comparing the belts, we're not actually shaping them. It's semantic, but it's a valid semantic. The other one is he's done the vibrations calibration. He's renamed that to create a vibrations profile, because we're not really calibrating it. We are basically creating a profile. There's a lot of changes here on this one. This one is the big one. A lot more information and a lot more getting lost in the information. This is the second time I've made the video, because the first time I got lost myself in what everything was. So let's take a look. So what we're going to do now is we're going to compare all the different graphs per version. So you can see that nothing here has really changed, right? Yet there is a similarity number here. please do not just go with the similarity number. It's about the shape of the graphs. This similarity number also is going to get reworked in an update. Right now, we're trying to figure out how best to describe it in a number because everyone likes numbers. But all of these graphs are really about the shape of the graph. So I know a lot of people on the Discord, when they're asking for help, they say, well, what's going on? I have a belt shaper that's like 90% or 30 or whatever number it is. Why is everything else off? And it really has to do with the shape of the graph. I'm using tap on this one, and so this is going to be my tap here, probably most likely. It's a tool head, 125 classic tool head, but everything else is good, and I'm not worried about this too much. My belt, so the input shaper for X, nothing here has changed. This is exactly the same. You will get a run-to-run variation. So if we go back here, let's go back to the belts, so you can see it clear. See how this one's above the green, this one's below the green? This is a run-to-run variation. It was run a couple days later. Actually about the same day. Yeah. Every time you run one of these tests, you are going to get a different response. It's just the natural process variation of running it. You will not really get two of them that are exactly the same. There will be some difference. So input shaper for X hasn't changed. Input shaper for Y hasn't changed. You can see here the run-to-run variation. See how it's going like that to like dipping in here to this one's kind of going out. Run-to-run variation. This peak here is most likely my umbilical. So here's the big change. This is the old version. This is the new version. So what's going on here, right? So the previous vibration measurement would basically cycle your tool head in one of four directions: A, B, X, or Y axis. And that would be the only angles it gave you. However, unless you're doing straight boxes, you're going to have other angles. You're going to sweep through the entire, unit circle from 0 to 360. So what Fricks has done is he's basically, well, let me back up. What has been found is that this is doesn't matter where you go on this, right? It's all fairly linear response. So what he's done is he's excited the B motors individually, excited the A motor individually, and then reconstructs this entire unit circle. If he was to go through and measure every single angle, we're looking at a 7-hour test. So basically we're stepping through the A and B motors, and then we are taking the sum of all these things and projecting it on a 360 graph, and it only takes 10 to 15 minutes to run. We're going to get into this graph, but you can see right now there's more information, and we've got to be able to dissect this information and figure out what it's telling us. Oh, I will say, warning, right? Let's do a big old warning. Warning. Core XY only. This test right here, this vibration measurement, is only valid for Core XY. It has no use. You really can't use it for like a Core XZ, a bed slinger. That's because of the motion systems on it, right, and the way it's performing the test. So if you have a Core XZ, your best bet, like a bed slinger, your best bet is not to update. Stick with this measurement. Stick with this one right here, because at least you'll get some values out of it for your Y-axis, your bed, and your X-axis, your tool head. But Core XY only. Now, is it applicable to hybrid Core XY? That would be things, such as the new rat rig coming out, and some other printers. I can't think of them right now. I don't know. We haven't tested on any hybrid Core XYs. Definitely not a Delta. You do not run this on a Delta. The information is just not going to be valid. It doesn't go through the proper axes. Delta's got 3 axes, as you know, and this is not set up for that at all. It's core XY. So let's get into the graphs. Let's figure out what we're looking at here. So as you can see, we have 6 graphs. This right here, this graph, this is the old graph. Oop, old. And we'll go back here and I'll show you. You see here, right there, those peaks. This is running in A, B, X, Y. This right here is XY. If I ran this, you can run the old test in ABXY as I stated. It will look like this. You will get another peak here in the between, and then you will get another peak, like this peak 2 here will get up. So this is the same test. This right here is the same test as this. So these two, let's go back here. These two are old. So it's the same thing we did. So that way, at least, if it's too much information for you, you can always kind of go back to this test here and do it. What is this giving you? Okay, so this is going to be your main graph. We'll go into all this rest of this stuff as we talk about this main graph. This main graph is basically giving you your, as it says, global speed. It's measuring all the vibrations from this unit circle from 0 all the way to 360. And what is it telling you? All right, so once again, it's the same as the old one. You want to stay in the green areas. So here is good, right? This little green is good. This little green is good. And how do we figure this out? Well, if you look down here, these orange things here, like this, right? These are the vibrations actually coming off your motors, and they're nice little wisp, if you will, or little torches from a flame. The brighter they are, so the more white they are, the stronger they are. And where they cross, sometimes you'll get another peak. So why is there a green here and why is there a white here? Well, if we take this peak down, if I can do this nice, right? We meet this line peak 3. Right here we got 2 vibrations crossing. We got a vibration crossing here, a vibration here, right? You just go down and you can see where all the vibrations are crossing. And so at this point, we have a huge spike because all the vibrations across the entire unit circle are adding up. Right, you can see the angle here. So this is your angle, this is your speed. And every single one of these, that's what's happening. That's what's giving you these peaks. So let's get down here at this area here, right? We'll look at this area. You see this little white zone here. And this little white zone is actually coinciding with this peak 1. Because this is where the tops of all these white vibrations are coming together. So it's best if you can do it to stay away from this. And so instead of using this entire range here, right, you want to use probably from over here or even just at the 25. Stay away from this kind of hump, this little area here. Let's get rid of all this here. We don't need it. Oh, we need that. Okay, so what are good speeds then, right? If this is to use speeds, what are good speeds to use? Well, anything, I would say I like to stay away a little bit from these tails, and I like to, stay on the grid because it's easier to read. So I would say about here onward. And that's what? 195, so this is 90. 90 plus, good speeds. So that you could use that for internal, externals. I would do that for ABS. ASAB. Oh, there's the SA. That's what I would do for a good external and internal perimeter speed. I'd be in this range, right? You just can't hit send though. You're going to have to do a print and see is anything else because of your speed. Is anything else coming up? But this would be a good place to start. The next, if you're doing PLA, I would probably be in this range here. So this is 50, this is 55. So maybe let's say 53. 53 for PLA. You could push it, right? You could say, no, I got enough cooling. I can do this. I'm gonna do, where's my? I'm gonna do 100 for PLA. I'm gonna go right here. If you have the cooling, you can definitely be up here in PLA. I mean, once you hit probably about 150, this range here for PLA, you're gonna need some pretty good cooling because you're going real fast, especially on smaller things. On bigger items, right? The bigger it is, the less cooling you need because the longer it takes for the print head to get back, and the more it'll cool up. But PLA, you could try it at 100. If you got the cooling, you can do 100. If you got the cooling, you can do 125, right? After this, after 125 for PLA, cooling, right? It's just going to be cooling. I don't like to deal with that, so my internals. So for me, I'm going to set my internals at 53. I'm sorry, rephrase. I'm going to set my externals for PLA at 53. And my internals, I'll probably set at 100. So my internals will be at 100. This is for PLA. And that's just because I don't want to deal with futzing with my cooling, doing a bunch of stuff. I'll take the extra time. I don't care. I want it to look good, and I don't want to like sit there and give every model its own specific profile on how I'm going to do it. I'm lazy. So this is a lazy way to do it because I'm just going to set it at 53 because this is what it tells me. So this is the meat and potatoes, right? So if we this right here, this is the meat and potatoes of what you need to know. This graph, the middle graph. This the middle graph gets its vibrations from this heat map here. Is there other questions are people give me is, well, why don't I run this to 500? Can I go up to 500 on this graph? You can. There's no negative. I will say it will be extremely slow for the tests. The tests will take a long time. The calculations will be extremely slow, and it may crash the system. We ran one of the Phoenixes, not on this current vibrations, but the old vibrations test. We ran it on the Phoenix at Rocky Mountain. It was set to 500, and it crashed the system. The Pi couldn't handle it. And the reason is that for every single frequency, this test creates its own individual file. And then it has to take a compilation and calculate from all the files. So you're looking, 200 files. Well, 199 because we don't count zero. So there's like 199 files there for all this stuff. And obviously it's doing a range. It takes a while. So, but is there a benefit, right? Is it worth waiting? Not really. As you can see, most of these graphs will go to zero. If you have any sort of good speed on your machine vibrations of a good graph like this, or a decent graph like this, it'll just flatten out. So, and as you get higher and higher, the energy imparted by the vibrations, the motor vibrations at those higher speeds is de minimis, so long as your rest of your system is good. So there's no benefit really in going above 200. If you want, you can do, maybe 300. But that's, it's not, if you're good here, you're most likely good way over here. And so just an FYI. So what is this guy telling you? Let's go to this polar angle. So this is telling you it's basically the same information, but it's broken it down a little differently. So what are we looking here? The shape we're looking for. We're looking for an iron cross. So the old German iron cross, right? Basically something like this. All right, let me draw it in case you guys don't know what an iron cross is. That's the graph we're looking for. It doesn't happen, right? We get close. Mine's pretty close. It's not too bad. And this is because I think Ellis in his Ellis print profile, Ellis's print guide, always has been saying for years, if you want the best graphs, you're going to orientate your parts at 45 degrees along your A or B axis. We have data now to back that up. So what is this? What is this showing us? Let me see if I can get rid of all this other stuff here, since we've talked about that. 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 I'll keep that over there. Who cares? And we'll get rid of this guy. And we'll get rid of the star. So, move this back over here. You're gonna, because when you're on one of the 45s or 135, let me get my drawing tool back. 45, 135. You're gonna be on the A and B axis only. So what that means is only one motor is going to move. The other motor is going to be static. And your tool head, you know, as you guys know, it's going to go in these angles here, which represent these angles here. And because only one motor is running, you're going to get less vibrations. So that's what we're seeing here. We're seeing, as we go through our different speeds and everything, we're seeing less vibrations in this green zone here. And that's what we want. You can get other shapes. So you can get what's called a butterfly shape. And a butterfly shape, it looks like, if you look at it from this head, so how does a butterfly go? Oh, good God. So we go like this. I think it's like this. And then like this. And then like this. Alright, and then like this. Something like that's not good, but it's however you draw a butterfly. That is what we're trying. That's generally a butterfly shape is going to mean that your motors, your A and B, aren't necessarily aligned, and that you need to tune them. Best tune so far, the easiest tune I would say, not that necessarily the best, but the easiest is TMC Auto Tune. Link in the description. The other one is a more manual one. It's called Chomper Resonance. I'll throw the link in there if you guys want to run that. But Andrew and I have done some tests to compare the performance of these two. You get different driver values for your TMC drivers doing the auto tune versus chopper, but the results appear to be the same. So while you're getting different results, the effect on like motor vibrations and stuff like that appear to be the same. So in that regard, I would say just do TMC Auto Tune. It's the easiest thing to do. It's just put your motors in. So this is what this is telling us. Basically, if you look at that unit circle, you can kind of use this to orientate your parts also. So let's say you have a structural part. You're obviously with like a lot of squares. You're going to put it on the 45. If you've got another part which maybe you can orientate it to get in these lower spots here, you might want to do that. But generally this is going to be where all your vibrations are coming from. And that's why you want to use this, because this takes into account the entire unit circle and figuring it out. So you're losing space, right? Like you're going to be losing at least one or two, potentially more. The white space is just speeds you can use for other things, but your perimeters. This is really just perimeters and potentially a top layer. So you might want to put your top layers, you know, PLA again. Once again, PLA. You might want to slow them down over here. Put them over here in 25 and less. So this is just another version of this in the heat map. So the way this kind of works is this map goes up to here, and this map goes up to here. You can see the different speeds on this one. So this one gives you the speeds. This is your power spectral density kind of thing right here, which is kind of like this. You can see that you get these vertical lines here, and you can kind of fine tune where you want to be using this one. If you don't like to set the global value, you can kind of use this one in conjunction with this one, depending upon the shape of your model. to reset the speeds. You can see that this right here, let's see, it's lighter. I don't know if you guys can see it. Yeah, you can probably see it. That's lighter. That's corresponding with this here, this green zone. And you've got little pockets all around, like a pocket here, little pockets. Maybe this is okay for you, so you're going to be more in this range. Maybe not, because there's a lot of vibrations crisscrossing there. But you can judge where you want to be. So this is all just to help you set your speeds. There's a lot in here, and these two graphs, I would go with this one. This is the easiest, 100%. So what else is this information? It's giving us some other information which I haven't really talked about yet. What else is it giving us? Well, Fricks went in and said, okay, how can we use this as a one-stop troubleshooting technique or as a record keeping, right? Maybe you're starting to mess with it. You're starting to mess with your driver values and you want to know what driver values did what. He stored them. So right here, these are your TMC drivers. Generally, these ones right here, the chop conf are the ones we're going to use. So from here over, T off, H start, H end, TBL, TB, TPFD. Those are the main ones. This MRes is your steps, or your micro steps. So if you set your micro steps to 32, this number would say 32. A minor at 128. Generally, on your XY, the more micro steps, the smoother your motors will go through. It may help reduce some of the artifacting of the step, so you get better circles and all that jazz, right? What else does he have? TMC. So you want to set, oh good God, what's that value? Let me look it up real quick. Set to true. I don't know the value name though. Interpolate? No, it's not it. Maybe that is it. Hang on. Interpolate, yeah. So this, if you have interpolate false, you want to set it. You want to set interpolate to true. It will get you a minor. You want to set that to true for this test. It will give you a minor, very minor positional error, but we're not doing CNC machining here, right? So we don't really care about super small errors. And the more you raise your micro steps, the smaller that error becomes. So set it to true. It'll make your motors quieter. It'll reduce the noise from your motors. So I don't think he has that here in this auto scale. No, I don't think it's there. But that, and then you set your step. So this will give you your TMC drivers. This right here will tell you if your auto-tuned is enabled. If your auto-tune is enabled, it will take the data from auto-tune and it will post your motors here. So your models of your motors. Mine are 42 LDO 42 STH 48 2804AH. If you don't have auto-tune, let's do draw. If you don't have auto-tune, you will not get the motor information. And this will say not enabled or disabled. You will still get, let me get rid of this. You will still get your driver, your current, your voltage, and your current. So that's the information you'll get here. And you can use this as you start futzing with stuff and messing with stuff to keep track of what you did. And that's why this is here, is kind of as a data keeping and making sure that you know what you're doing. So it's always going to be Core XY because this thing is not really going to run too well on I said, Core XZ. So the acceleration, what should you run this thing at? The acceleration, as I said, you want to get this machine. Let me back up. You don't want to measure the effects of acceleration on your tool head, on your accelerometer. You want to measure the effects of being at a constant speed. So if you start increasing this, you're going to increase noise because we're moving this tool head up. It's going to vibrate as we saw in Input Shaper. And then when you stop the acceleration and you go to constant speed, your tool head will still have some vibration in it. right? It's not gonna, it's because it's got a damping ratio as we saw, so it's gonna take some time for that ringing to cancel out. If you have this too high, you're not going to cancel that ringing out when we're taking the measurements. So it's going to show up on this graph, and this graph is going to be a little bit more crazy. So 3,000 is about the fastest you want to go for this. You can drop it down, that's fine. If you drop it down too low, you may not get to your speed, right? So it's a balancing act. After several iterations of testing, 3,000 was found to be a good acceleration for this test. So I would say if you want to play with it, go ahead, but don't rely on the values. Rely only on the values that you use at the default acceleration. So let me see. I'll read you guys what Frick said. 3,000 Excel is not the max. It's just what I found by testing what works best for the predefined size and max speed of 200. So the predefined size of this is 60 by 60. If you put more Excel, you will get faster at a constant speed, but then in the corner, when the direction will change, so that's when we're going like this way and then we change directions, the inertia of the tool head will continue and make it oscillate at a low frequency and high amplitude. It will create a peak around 0 to 50 hertz on the motor profile. So the motor profile is here. 0 to 50 is around here. You're going to get a spike here, is what he's saying. If you want to go above 200, you'll need to look at the first peak and see if it's okay or if it needs either lower Excel or increased size. So the first peak being here or here, if you go faster than this, you may need to start adjusting the size of your test area and the speed. That's what he's saying. If the low frequency peak is not there at all, Excel can probably be increased a bit, but it will not lead to any benefit besides the test that will run quicker. And too high Excel, he's going to add a warning for 2XL. So basically, if you go faster, your test ends sooner. You get no additional information, but you have run the risk of getting bad data. So my advice, leave it at 3,000. You'll be fine. So let me see. I'm checking my notes here, guys, making sure I'm giving you all the information. Okay. So that's basically it. That's all my notes. The symmetry on this one is better than the symmetry on Belt Shaper because we actually have something to measure symmetry with a circle, right? So the butterflies and the other shapes, we got some weird shapes, some really weird shapes. Generally, you'll get them when you're using the default chompers or the default TSM drivers provided by Clipper. 100% recommend installing TMC AutoTune. It's a free. It costs you nothing. There's no real performance negative. You just you're getting better values in. TMC AutoTune is a calculated value based upon your motor characteristics. That's why it needs the motors. Chopper, which I'll put a link in the description, is based upon the actual performance. So that's why there's a difference. But the calculated and measured, we didn't see our performance changed in real life. But there's two methods, and I'll put them both in the link. So that's the new vibration measurement. It's going to be crazy. I know I'm going to get lots of questions on what does this look like, what does this do. I will say focus on the shape here. So this one you want the shape. And this one, it's once again stay in the valley. You want let's just valley. Stay in valleys. So valleys. Stay in these valleys. Gets cold up there on the mountaintop. So that's the takeaway. Now, I did run another test, and I did it without AutoTune. As you can see, I got an Iron Cross. There's a 5160s. I've talked to Andrew about this. Like, why am I getting this? What is going on? And, basically there's a lot more noise in the system here than there is over here. And so you can see my main peak is up here at 7, almost 8. And here it's lower, right? It's not even on the same. So it's 1, 2 there. 1, 2, 3. So it's a little higher here. I don't know why this is. Honestly, I don't. I'm going to have to keep digging into it. But there is, as far as I understand, there is more noise in the system. And I don't really have a good reason, because the data looks better without it right here in this one. But I did have an increased current. I reduced the current on this one. Not really of an effect though, right? So I don't know. I mean, there's still stuff I'm learning, and this is one of them. I ran it to see what would happen. This is what happened. Providing you guys the data. Maybe you guys have a suggestion on what the hell's happening here. You can see that the drivers here have changed a bit. So, but in generally, I don't know. But this is the new update. I'm gonna have to investigate, right? This is the new update on Shaketune. If you have any questions, feel free to ping me on the Voron Discord. I am generally hanging out on the Residence channel, and or if you can't find the Residence channel and you're in like the V2 channel or something, just ping me. Or if you something like that, I'll come and take a look and see what's going on, help you out if I can. But this is the new one, and yeah, thanks for your time, and hope you have a good day and good morning and or good evening. Bye.